All right, so this morning we're going to be looking at design patterns, and you would have done a video on design patterns, a few videos on design patterns. How many people are able to go through all those videos? It's quite. If the videos are hard to follow, you can use like some students, some people like me. I find it takes too long to listen to the whole explanation. Like it's easier for me to read it sometimes, unless it's something I don't understand. So you can use the textbook that I gave you as a reference. You can look at the slides, and you can also go online and look for the patterns, and you'll see explanations on the patterns. Don't use Stack Overflow too much until you think you understand it well, because sometimes people put some things that are not so correct where design patterns are concerned. Yeah. If composite is, yes, it's a design pattern. It's not in the slides, but I'll tell you about it. And I'll give you an example of it. And it was actually on, there was actually a composite pattern on a quiz that you did week before last. Yeah. All right, so we're gonna start. Let me share. Oh, you guys haven't been hooked up. There's a problem with the projector again. Just switch this one. All right. So we're looking at design patterns. We're looking at design patterns, and it incorporates a lot of what we have learned in terms of lost control of the mouse. Can you guys see the screen? People at Cahill, can you see the screen? Those of you online?
Not at the moment, no.
Okay.
No.
Okay, I had a little bit of problem with the computer. I'm sorry.
We can see some video.
All right, sorry about that. So let's go. So we're talking about design patterns. Textbook that we're going to use as a reference, and you can use other books because design patterns are well documented in many catalogs. Aside from this book, but I find this book to be very concise and a very easy read. And I know nowadays students don't really want to read a lot. You want to read it. You want to get the information very quickly. This book is very good. All right, so what's the motivation for design patterns? I'm not going to go through this slide in detail, but essentially, how many people want to be programmers when they graduate from university? How many people want to be software designers or software architects? Why would you prefer to be an architect over a programmer, or a designer or engineer over a programmer? Why? If you can choose both of them, let's say you can only choose one, and really, unless you're developing small, unless you're in very agile environments, small environments where they tend to develop smaller pieces of software, you may find that people play more than one role. But essentially, you will have at the level of taking the requirements and deciding on the architecture of the system. You usually have somebody who's an architect. Exactly. Usually you come in as a programmer at a junior level, and then you might go into, you might move from junior programmer to senior programmer to developer, and then you might get a tech lead or software development lead or team leader, and architect is really like way up at the top of the scale. How long do you want to take to move from programmer to architect? 2 years? How many years?
1 week.
1 week? What else? So you want to take a few years. You don't want to take the point is that you want to take as short a time as possible, right? No. The issues, you have been programming for at least 2-3 years. Most of you are here. You have done some programming probably in sixth form, lower six, upper six, and you did a little programming. Then you came here, you did some programming and so on. Over that time, you would have learned some tricks, right? Over the time, you realize that, oh, you know, if you do certain things in a particular way, you have certain problems. And little by little, and you might even make mistakes several times before you realize that the best way to organize software when you have this type of problem is to do that. Over time, you have learned patterns. You have learned some design patterns. You have learned some patterns in terms of how you code. For instance, you have realized over time that if you want to do something to a large collection of data, a large collection of objects, you would create a collection and then use an iterator with it, right? Or you would have a for loop and go through it. You wouldn't like make a whole bunch of variables and then do things to it. Those are patterns that you're learning at the programming level. At the design level, we have design patterns that help us to make decisions. Many of the problems that we want to solve at the design level have to do with reducing coupling. Remember, we don't like coupling. Has to do with hiding implementation details because we don't like to expose implementation details because it makes it more likely that a program breaks when you're trying to make a change. We want to make classes as cohesive as possible. That is the focus on primarily just one thing. And we want to figure out in different situations. Sometimes it takes a while to figure out how to achieve that. So you'll start from a certain point and you'll make a lot of errors and keep changing and changing until you find something that kind of works. Most problems in software engineering are common. So if you're developing a HR information system or a point of sale system or a student administration system, a lot of systems have many commonalities, even though they might be for different domains. There are a lot of things that are common. And so there are certain problems that you will encounter when you try to develop large systems that people have encountered already. And after they've encountered this problem several times and solved it and used that solution in many different situations, they share that solution with other colleagues, other organizations, they publish it in journals and so on, and people get a chance to reuse them. We call them patterns. something doesn't become a design pattern because Kenneth was doing his work and he figured out a way to solve a problem, and then he says, I have a design pattern, guys, I got to use this. It becomes a design pattern after it gets published and reused a few times, and people find that it's applicable as a generic solution to similar types of problems in different domains, right? So the idea is that if you were to wait, if you were to always have to solve these problems on your own using your own original ideas, it would take a much longer time for you to move from programmer to designer or architect. And so there are catalogs of design patterns. You don't really need to memorize design patterns. In real life, if you have a problem, you're doing your coding, you're doing your designing, and you said, boy, you don't like coding stuff because you realize that these classes are very interdependent on each other, and you want to see how you could manage that situation, but then you realize that you see different types of issues. You look at a design pattern to see how you can, you look at a design pattern catalog to see what kinds of problems, look at the problems that you have, and then you look for the solution here that matches it. Problem solution here that matches. So an idea, the whole idea of design patterns didn't start in software engineering. It started in construction, in civil engineering. And you know that one of the things that we aim for in software engineering is to treat the discipline as an engineering field, not as a, software engineering is not accepted right now as a part of engineering discipline. Everybody knows that? Yeah, so if you know the Jamaica Institute of Engineers, for instance, they include civil engineers, industrial engineers, electrical engineers, chemical engineers, process engineers, all kinds of different engineering fields. But because software engineering deals with engineering of non-tangible products, because software doesn't seem to be tangible to people, they don't know how to handle it. And also, software engineering is a new discipline in comparison to the other engineering fields. And so there aren't as many standards and guidelines and so on that govern it. We don't use as many processes as the other fields of engineering. We kind of do our own thing, right? But the use of design patterns is one of the things that helps to bring software engineering up to an engineering, but something that you can code and develop a standard for and say, okay, if you're an engineer, you did engineering at school, you don't just become an engineer because you studied engineering at school. You learn some processes. You go into the industry and you start applying those processes, applying those standards, applying those rules and so on, and those design patterns. And over time, we decide that whatever is the legal body for giving you the status as an engineer in that particular jurisdiction, we can apply it the engineering status. We want to do the same thing with software engineering, but one of the things that we want to do is to be able to have processes, standards, guidelines, and so on that help people to produce the same type of quality results independent of who you are. So if you have standards like patterns, whether I am solving the problem or you're solving the problem, it's not all left up to my unique interpretation. The obvious problem is there. It's a documented problem, and you can draw on a particular design pattern to solve the problem. All right, so imagine you're in the late stages of designing a library automation system. The requirements call for a system that will allow a library patron to check out a book, return a book, renew a book, and place a book on reserve. So our use case diagram will look something like that, right? We're used to that. And our initial design might look something like this. We'll say that, well, we need to have a book, and you can have book copies, and patrons, books can be assigned to a particular patron. If we look at the fields, we can say a little bit more about the details. I've lost my mouse again. So for example, if you look at patron has a list of book copies or a collection of book copies. What's the name of the attribute for the collection of book copies? Can you see it? Books checked out. So that's a collection of book copies. Book has been returned, takes a book copy. Notify patron of book availability, takes a book, that's the original book, and you can borrow or check out a book copy. book copy has an instance of book. So in other words, a book copy references a particular book. Everybody seen that? The relationship, that's the arrow that goes from book copy to book, is telling you that book is an attribute. There is an attribute of type book inside of book copy and so on. So there's some relationships between all the elements in this domain. Now, when we build a user interface, so let us say, and this is an extremely simplified example. In real life, we'll be looking at a model that has maybe 40 classes, 50 classes, 60 classes, and you want to build a user interface to allow the requirements, allow access for the user to access the different user requirements, right? So what were the user requirements? We need to check out a book, return a book, renew a book, reserve a book. Now, in order to, if you look back at this, in order to check out a book, you see that highlighted operation inside of Patreon. In order to check out a book copy, check out a copy of a book, we need a book copy object. So that is actually a dependency, remember? That's actually a dependency on book copy. So if we were to, right, so that's a dependency on book copy. We also need to place a book on reserve, and that requires a copy of a patron. They need to instantiate a patron and pass it to that class and so on. In order for those services to be available to the user interface, so the problem is, and a common problem, in order for those services to be available to the user interface, you're to write a user interface class and try to access those services. It requires you to interact, the user interface must interact directly with book copy, and patron. And although it seems like it's not really high coupling, it is high because you only have 4 classes there. So if you were to extrapolate this to a bigger model, what you're saying is that for there are 1, 2, 3 links for 3 classes. And that is actually kind of high, especially when you consider that there are different kinds of methods and different kinds of services that may be that the user interface will need to access. Different services might collect different requests or operations might be available through different interfaces. When we like, we'll end up with a number of different interfaces that the user interface has to ask questions of. So how do you solve a problem like that? You realize that this is more coupling than you want. You want the user interface. Remember, a UI is not a part of the domain. A UI is not an entity class. A UI should not have to think a lot about, okay, in order to place a book on reserve, I need to get the patron object, and I need to get the reference for the patron, get the patron from the database, rebuild the object, pass the object to the book class, pass the patron object to the book class, and in the operation place on reserve, there's going to be, okay, a search for the book, and then a search for the book copy, and so on. User interface is not really interested in those kinds of details, or you would prefer that your code for your user interface would just simply make one method call for whatever service it needs. Wouldn't that make sense? Yeah, you don't want the user interface to have to think about the logic, the business logic for that particular process. And so this is high coupling, and you don't really want this. It's not like you're not going to work and it's going to work. But the problem is that if you need to change the user interface, you have to think about a lot of different things, as opposed to just simply saying, still just call these particular methods from the interface. You end up with a number of different steps that you have to take, which is not what you want. So how do we solve a problem like this? We check to find out if there are documented solutions to the problem of a user interface or a client class. And it doesn't have to be a user interface. It can be any client of the overall library service. So let us say that you are building a web app, a mobile app to interact with that system. You would also not want to have to think about the details. You want to have an API that just says more book, lend book, that, right? You wouldn't want to have to think about the logistics. So you try to find out, no, is there a pattern that will help me to solve that problem? So you take a design pattern catalog. This catalog is one of the, like the original design patterns catalog. People who are known as a YAML 4, right? So every YAML Hell, Johnson, and UCs. They're known as the Gang of Four. And I think there's somebody else who eventually they called the fifth person, like the Gang of Five. But anyway, then there's Head First design patterns. Everybody knows the Head First series. The Head First series is loved and enjoyed by many young people because it has a kind of a cartoony, comic kind of way of teaching concepts in software engineering. So you can find there's object-oriented programming in Java, they have C#, they have design patterns, they have UML, and so on. But there's a kind of a lightweight approach to teaching that a lot of persons find very attractive. They use like stories and little cartoons and people talking and conversations and so on to go through the topics. So you might want to do that. There's this book, that's the one that we're using. And there are a whole lot of others. And in fact, if you go online, there are also online catalogs. So you can, if you Google design patterns and you find a website that has 30, 40, 50 design patterns, that's considered a design pattern catalog. This book only has about 10 patterns. So this one has about 20, like close to 30 patterns here. But design patterns, elements of usable object-oriented structure is very old. Very, very, very old. So you don't need to, I have that book. It's very old and the examples sometimes don't relate to persons of your generation. Some of this one design pattern and also the online ones will use more modern things. So they'll use mobile applications as examples, ebook readers, all kinds of things that are more modern. All right, so let us set the first pattern we find is a singleton pattern. Singleton is the name of a pattern. We look at the description or the intent of the pattern. It says, singleton design pattern ensures that not more than one instance of a class is created. That's not relevant to our situation, right? So you move on, you look for another pattern. Another one is the iterator. The iterator design pattern provides information, provides a uniform way of traversing through a collection of items. That's not relevant to us either. And then there's the facade. The intent of the facade design pattern is to provide a unified interface to a set of interfaces in a subsystem. So if you have a number of different interfaces designed to provide different sets of services that need to connect, and there's a client or some other interface that needs to connect to it, and I'm going to go back after this interfaces. Don't know the interfaces. They have these interfaces, they have some external clients, some other clients or another part of the system, a component or something that needs to utilize the services of this interface. But you find that you have to be going to many different interfaces. You're going to have a lot of, increasing in coupling in order to facilitate, to complete the requirements. You might decide that, okay, you don't want to do that. So instead, you provide a facade, and the facade deals with the messy work and then gives you a nice, clean interface that any client of that particular set of services can have access to. So if we apply the design pattern, the facade design pattern, we'll have a library facade now. So we don't care that the user interface now doesn't need to think about the book copy and the patron anymore. Instead, the library facade needs to be able to check out a book. And it just says check out a book, and then the library facade takes care of, okay, who is borrowing the book, which patron is borrowing the book. Does the person have any books outstanding? Can they be allowed to take this book? Is the book what you call it, a reserved book or a takeaway book, and so on and so forth. All those things remain outside of the view of the user interface because of the library facade. Do you have any questions about this pattern? Do you think that the coupling is ready reduced?
Yeah. Not really.
Huh? Somebody said not really. Come again? From the perspective of the interface, right? It is improved from the perspective of the interface. And is that really important to just transfer the overload to somebody else? Come again? Okay, it is important just because so you can still see that these three connections are still there. So it's like, well, you know, what's the big deal? Big deal is that this belongs to this part of the system. So basically, you're saying it's another way of hiding the details of the implementation. So this is the library system. All of this was the library system. And that was the user interface. The user interface is not really a part of the system. If you think about how we architect system, we tend to support, separate the UI from the logic layer. And user interface is only one example of something you want to separate from business logic. Sometimes it might be that you have, and not the way that you have designed the system, there are other services that you want to access, a set of services in that layer. So it's basically what you're doing is using this to hide these details. So it's another way of hiding the details of how the problems are solved from the user interface. That at any point in time, you are free to change how book is implemented, how book copy is implemented, how patient is implemented, how borrowing of books take place. So any of these method implementations can change. And all you have to do is ensure that interfaces remain the same. Interface remains the same in the library concern. So it gives you more flexibility as a developer. When I see through this history thing, you guys are going to read that, right? I want to go to template. All right. One-off designs are not design patterns. So like I was saying, if you do something to solve a problem today and it worked well for you, you feel great about it, it's not a design pattern. You might use it again because it's your pattern. You invented it and you might use it again. But how you know it is a design pattern is when you have used it to solve the problem in your context and you tell, Kenneth tells, what's your name? Shamar, and Shamar uses it, and Shamar examines it and feels within himself and among his team in his organization that this really does improve upon this thing, and this is a good way, this is probably the best way we have found to solve a particular problem. And then Shamar puts it up on his maybe he has a website where he shares solutions that he has found, you know, he puts it up and other people start using it and people start giving feedback on it. After a while, we can see that that's a design pattern. I'm not going to go through this because we have spoken about the benefits of design patterns with our story in the beginning. Intent matters. One of the things is that the design pattern is not all about, first of all, it's not nailed down in concrete in terms of how you implement the design pattern. So you'll find is that I might show you an implementation for a composite pattern and you'll see it somewhere else and it looks different. I'll show you an implementation for factory and it looks different. So I might use inheritance and somebody else might use an interface. So it's really the intent that is important. One interesting example is state pattern and strategy pattern. Anybody recognize anything interesting about state and strategy when you were doing the videos? Because I know you listen to videos and the quiz and you went and did more research and so on. State and strategy. Did you notice anything? There's a hint on the screen. It helps, yes.
Strategy that is almost the
Turn on the volume.
for strategy are almost the same thing in state where you have to listen for state.
Okay, getting there. What else? Anybody else? So if you this is not state and strategy. We don't know which one it is. These two patterns are exactly the same, right? Suppose I told you that they're different. One is state and one is strategy. The idea is that state and strategy have exactly the same structural makeup, exactly the same. But a strategic pattern is used to implement algorithms, a particular algorithm based on an object type. Yeah, So it basically causes you to have a different kind of algorithm based on a particular state or value. Whereas with the strategy with states, you're applying a particular state. You're actually saying that certain objects of the same family have a particular state value. Whereas in strategy, certain objects are states of the same family, that is children objects. They have everything the same except for there's a particular behavior or a particular algorithmic behavior. How they solve a particular problem is different. So for example, you can have 4 different kinds of students in your system and your registration process was different. Then you could use a strategy pattern. But if it was a case that you wanted the values, the state of the object to be different, then you use state pattern. And we'll see shortly. So it's of course impossible to tell which is state and which is strategy. Structurally, they're identical. Design patterns aren't distinguished by their static structure alone. What makes up a design pattern is its unique intent. And there are some patterns that it's and there are some patterns also. If you look at this catalog, won't tell you all those, the way that slides are, you won't see the you'll see that some patterns are related to each other. And they're frequently used together. So the intent of a pattern is the problem solved or reason for using it. The intent of the state pattern is to allow an object to alter its behavior when its internal state changes. The intent of the strategy pattern is to encapsulate different algorithms or behaviors and make them interchangeable from the client's perspective. Now, every catalog uses a particular template for the design patterns contained within it. By template, we're talking about things like what's the name of the pattern, what's the purpose or intent of the pattern, what are the elements within the structure or the structural layout, the elements within the structure of the pattern, and also usually, well not usually, always includes UML diagram that describes how the elements in the structure are connected to each other. The UML diagram by itself does not really define a pattern because the pattern has to indicate to you what is the problem, the issue that needs to be resolved, and then how it is being resolved. And then that's where the UML diagram has a context. Without that context, it's just a UML diagram. Make sense? And also in the code. Yeah. So, good, very good question. So you tend to have your design pattern in your class diagram. That's what it tends to show up in the class diagram. You can also, the sequence diagram is a dynamic expression of the relationships of the classes. It just tells you that this is what happens in real time with these objects. This is how these objects interact. But the class diagram is mainly class diagram, and to a lesser extent, the object diagram is where you're going to see the design pattern. You can also see design patterns in component diagrams and package diagrams and deployment diagrams, but those are different kinds of patterns. They're primarily architectural patterns. So there are patterns, we did architectural patterns in software engineering. The diagrams in UML that we tend to use to represent architectural patterns as higher level patterns are component, package, and deployment. And you can also use class diagrams as well. But design patterns, I skipped through those slides, but there are a set of slides that actually talk about different kinds of patterns. I didn't go through them but they're on the slide. One, because of time, and also because you are going to see architectural patterns. You have seen them before. I'm going to talk about architectural patterns later in this course. So design patterns are almost always presented using a uniform structure. Having a consistent format makes it easier to learn, compare, and use patterns. It's very easy to search, for example, a repository of patterns if you can search on the intents. or you know what fields there are, you can search on those. So an example template, an example that you'll see in these slides is the name of the pattern, an introduction or motivation or purpose of having the pattern. The intent is the design problem the pattern addresses. The solution is the static, structural, and dynamic behavioral aspects of the solution. So one, it includes usually the dynamic part is usually shown in an explanation. Sometimes they'll include a sequence diagram to show you what would happen in real time. Right? But what is always there is that static structure represented by a class diagram. Sample code, very often there's a little sample of C++ or Java code. I'm sure there are newer catalogs that have Python code, but usually it's a Java or C++ or C#. The reason why is because they are like the long time tried and true object-oriented languages that kind of map very easily. And those languages also have constructs inside of them that are explicitly like the constructs in UML. So inheritance has an explicit construct, interfaces have an explicit construct, and so on. And then there's usually a discussion, and the discussion usually talks about some of the implementation issues associated with the use of the pattern. For instance, if you talk about a composite pattern, it will tell you that you have to make a decision about whether you're going to meet the parent component, the abstract, or whether you're going to leave it as concrete. And therefore, if it's concrete, then you have to decide on whether or not all the objects from the concrete implementation, concrete class, and the children class, if their interfaces will be exactly the same or if there's going to be a variation. You have to decide on how that impacts upon the solution that you are doing, or the context that you're going to use it in. So one of the important things to recognize is that there's nobody, when you pick a design pattern to use, nobody is forcing you to implement it in an exact and specific way. You have to look at it and figure out how it solves the problem and then apply it to your context. Patterns related patterns are patterns related to the one described. So we're going to talk about singleton, iterator, adapter, decorator, strategy, factory, observer, facade, and template. We're running out of time, but I'm going to start anyway. The singleton design pattern is very simple. Singleton design pattern ensures that not more than one instance of a class is created and provides a global point of access to this instance. So let us look at it. So you have a client that has a particular object, and but in this case we call the class singleton. You don't have to name it singleton, people, right? So you have a class, you have a system or another class or something, and it has a singleton as an attribute, and you want to make sure that there's only one instance of this object, of this singleton ever created. So what do? We create that instance within the singleton class itself. So inside of the class, you'll notice that we have a private instance called a private instance of type singleton, right? And then we have a constructor here which is private. So the constructor is private. What does that mean? Come again? Nobody else can instantiate it. So the only instance that can be created is an instance that's created in the singleton by a singleton object. And then we want to be able to return that singleton object to the client that needs it. And so we have this method, getInstance. And then let's look at an example code for that method. Now, your code might not look exactly like this, but the idea is that you want to force the code to recognize whether or not a singleton has been created already. And if a singleton has been created already, then it means that the instance value inside of the singleton should still be null. Sorry, if it hasn't been created yet, it will be null. And therefore, you're free to go ahead and create that using the new singleton method. And then you can return that instance. Now, if that wasn't the case, what would happen is that it would return the same instance. So that's basically how singleton works. Then there's the iterator, which you should be familiar with in Java, because Java implements iterator, and Python also has iterators. You can do an iterator implementation in Python, but basically, the iterator design pattern provides a uniform way of traversing the elements of a collection of objects. Now, interface. Iterator and collection are interfaces. It means that they're in UML, they look like classes, but they always have the stereotype interface at the top. It also means that the methods that are in there are basically like abstract. They're never implemented. And some other class has to implement them. From Java, everybody would remember that, right? They can implement an interface. So concrete iterator realizes this dotted line, dashed line with the arrow, head, open arrowhead. Notice that arrowhead is like inheritance, because implementing an interface is kind of like, realizing an interface is kind of like inheritance. You are going to provide, you're going to override each of those. So anyway, this is called a realization arrow. So the concrete iterator realizes iterator interface. And then the concrete iterator has a concrete collection inside of it. And that concrete collection realizes the collection interface. Now the next thing is, if you look at the create iterator function, it will return an iterator, right? If you look at the interface, you see that the interface is designed with a method that returns an iterator, but you want to specify what kind of iterator you are going to return. So the concrete iterator has a concrete collection that can create an iterator and return that iterator. And it's doing it for the particular, it's doing it for the, that iterator is specifically for the concrete collection. So once the concrete collection creates that iterator can be used now to actually do the has next, the next, and the remove functionality of any iterator. So the point is that remember that even though you're only seeing one concrete iterator here, you could have several different concrete iterators being realizing the iterator interface. Likewise, you could have any kind of collection or any kind of concrete collection. You could have multiple ones realizing the collection interface. At the end of the day, this collection now has an iterator that can perform next, has next, remove, and whatever other functionalities related to iterating through. If you look at the code for create iterator, you will notice that it passes the collection to the function that creates the iterator. Can you see that? You notice that it says concrete iterator this. So it is the concrete collection that's being passed. So the iterator that is created to iterate that particular collection. The implementation for concrete iterator now will take into consideration the type of collection. So if, for instance, it's a queue, the way that next will be implemented is different from how it will be implemented if it was a stack. If it was a set of student records, next is going to be implemented differently. What do you want from next? And that's the point, is that you can get an iterator that's relevant to the particular collection. Everybody see that? And that's important if you have many different kinds of collections that need to be treated differently. But the interface being consistent is useful to you. Adapter. Adapter is another very useful pattern. An adapter gets utilized or should be utilized when you find yourself in a situation where there's a set of services that you want to access or some functionalities that you want to access. You have a component that does it, but the client or your code that needs to use it is expecting a different type of interface. Understand? So for example, let us say that you have the operations coming. Let's say that your code is written so that you have the operate, you're expecting to be able to access an operation called get token, return token, display token. And there's a component that has exactly the features that you want, but it doesn't have the functionality get token, return token, and display token. Instead, it has get student, return student, but it does exactly what you want it to do. It's just that the way that your component was written, it expects a different interface, and that interface will mean the actual methods that you're going to be calling. Then an adapter is useful now for adapting, you know, like if you have you go to Europe and you have those plugs, the kind of plugins that we have, and you want to use the European socket, then you have to put something on it to change it. You plug something into the socket so that it looks like the socket that you're expecting. That's an adapter. It's the same principle. You had a question. If it could be useful in the first example, what's the first example again? Singleton? Iterator? Ah, so it's kind of different. The difference with the facade and the adapter is that with the facade, it's not as though you have an interface that is, you have a component that is useful the way it is, but it's just that the interface is a problem. With the facade pattern, you're using it because there are many interfaces and you want to pull them together into one uniform interface. So it's similar, it does adapt, but it's like if you had, let us say that I needed to, this would be kind of like the facade. This device, it's a USB hub, and so I have all these different things. It's not exactly the same, but I have many different things that I need to interface with. But all I want is just one thing to interface with. I don't want to have to think about, okay, I need to connect to this, I need to connect to that, and so on. So instead, I get something that I can connect to one time, and that thing deals with all the other details. That's like the facade, but the adapter is really a one-to-one relationship. So let's look at that. So the client would represent the object that wants to, the object that wants to utilize a particular feature. So if you want to think of it very, very simplistically, if you had an object or if you're defining a class, and in that class you had a particular object, and that object does, say if you did an import and you have access to an object, the object does exactly what you want to do. Exactly what you want to do. But the way that the interface is designed, maybe it has a parameter type that you don't want to use, or maybe it's asking for 2 arguments, but you only want to provide 1, or the name of the operations are different than what you're expecting. Then that's where you need an iterator. That's where you need an adapter. So the client has a particular interface. The client wants to utilize a particular interface. In other words, the client is designed with certain function calls in it already, right? Yeah. With certain function calls in it already. So maybe that is it's doing an upgrade and it's changing a particular component that you would normally utilize. But the component that it finds that allows it to upgrade has a different interface. Instead of having to change the code in the client, which might have other implications later on, you use an adapter. So the client has a particular interface that it expects. It expects this particular method. It expects an object with a method client expects. Everybody get that? Yeah? So what we do is we create an adapter. But we create the adapter to realize the behavior that the client expects. And then we allow the available service. So it takes the available service that needs to be adapted as an attribute. So that is the adaptee service available. Adaptee is of type service available. So now the adapter, which has the method that the client expects, takes this service, and then what we'll probably do is have another function that makes whatever changes and causes this artifact, puts the call for the method that's available inside of this definition. So still have method client expects. What's the definition? The definition is taking the object from the service available and running the method that's available and returning whatever it is. There's no return here, so that makes it really easy. But basically, the method call that client has will do is for the client to get, the client wants a particular service. But that service is only available in a method that has a different name than the method that the client has. And many times people want to change the client's code for different reasons. Right? Maybe there's other code that would end up breaking if you change that. And so basically what you're doing is wrapping the service that is here in a service that looks like what the client expects, and then client gets what wants without having to think about the details. Make sense? And these are very simple examples. Might be different when you're actually trying to implement it. They're simple, really, you know. It's just to recognize that that's the problem that you have. Sometimes it might take some time before you realize that that's the problem and how you apply it. You can also do the solution using inheritance. Remember, I said to you that the design patterns are not nailed down in concrete how you're going to apply them. Many things can be achieved through either inheritance or aggregation. Remember, we spoke about that? So here we can, in this case, we're achieving it through, what is this? This is an association relationship, which means it's a containment relationship, right? Yeah? And we're using realization in order to get the adapter to provide implementation details on method like this. Right? But let's look at this one. This one says, well, the adapter still is going to be realizing or implementing or providing implementation for the method that client expects. Right? But how does it do it this time? This time it inherits service available. So the way in which it is able to give us what method the client expects is by using inheritance. So it takes a method that is available and it has access to it now, so it can still the wrapping fusion. Same thing. Just a different way of approaching it. And then there's a decorator and some others and so on. But what I want you to do is just go through them. Any questions? No, and other thing I need you to do is to look back at lecture 4. Let me just switch to lecture 4 for a second. Oh boy. I can't find my mouse. Okay, if you look back at lecture 4, the last about toward the end of lecture 4, there was a section on interfaces. Most of you know what's an interface from Java, from 1161. But I want you to look at how we represent interfaces in UML. And there are two different ways. There's a way where it looks like a class. And another way is where it looks like a class. And you have other components that either realize it that is implemented or provides it. Sorry, or requires it. So you have providers of interfaces that is the one to realize it or implement the details of it, and others that need to use it, like use an instance of it. One way of showing that is by using the class to represent an interface, a class box, and you put the stereotype interface, and you use the realization arrow, that's the same dotted arrow that looks like inheritance with dashed arrow, that's realization, and then a plain dependence arrow, that is a regular dashed arrow to represent that you require or you depend on it. Another way is using a ball and socket. Just a circle as the provided interface and the socket. So maybe next time we meet, we'll start from there. I just want you to be able to see it and relate to that as well. All right? So those are the two ways that you can see interfaces. Okay, oh, there's a question. Hi, everybody online. I realize that there's a question. I cannot see the question. If somebody has a question still, can you just ask the question? With your microphone, I can't see the comment. Something, I'm having a problem with my computer.
No questions here.
Okay. All right, then. Okay, guys. I'll see you next time.
All right, thanks. Bye.
I don't know how I'm going to shut this down.